we want to do a quick overview of the Rare Parts Project team and the 22 years that we have been involved in additive manufacturing with NCMS, and starting with the Mantech program, which is why their symbol is up in the left-hand corner, and was picked up by CTMA. So we have had an uninterrupted program for this long a period of time between those two funding organizations. Next slide. This slide is primarily not for you to read, but to visually see how many additive systems have been developed and entered into the marketplace since it first came out in the 1980s. You can see the growth in the 1990s and the 2000s. There were explosions of number of introductions of new additive processes by various companies. And those in bold print, when you get printed copies of these, it'll become apparent. Those who are in bold print are the surviving entities going forward into the 210, and those who are listed under 210 are those new companies that have come up so far in this decade. Now we are entering another period of explosion and proliferation of 3D inventions, innovations, and companies entering this marketplace again. So we're liable to see that column grow extensively through the end of this decade and into the next. Next slide. This is a timeline, just to give you a little bit of an overview. We won't go into it in detail, but we started out as a rapid prototyping program back in 1991. That was funded by the Air Force Mantech organization. And in 1998, we issued an industrial roadmap for additive manufacturing, but back then it was called rapid prototyping, was the popular term. Then in 1998, we actually entered into the agreement with the OSD, Maintenance Policies and Programs Office, with a collaborative agreement. And we took over that particular vehicle to launch the next phase of that rapid prototyping program. And so that began in 1999 and has continued uninterrupted until today in 2013. Rare Parts today, what I want to tell you is that when we first started back in 1999, the context of the program involved transitioning and teaching the depots how to perform various case studies using additive. But the additive technologies resided in our industry partners. And so our industry partners performed these studies for depots as a learning technique. We have transitioned over the years into introducing machinery. We have introduced 24 machines into both the depot and industry participants. We always selected either machines that would help the depot learn a technology, or at an industry partner, something that was either a beta machine or on the cutting edge of a new technology introduction. Could you bring that slide back up? Thank you. All right. So then by 2009, we started the phase that we called Rare Parts. And the Rare Parts phase denotes that the depots have actively started acquiring their own equipment, they're hiring their own expertise internally, and they're identifying and applying additive to their own internal applications. And they turn to the team now for advice, lessons learned. Everybody shares what they have learned over the years with one another to get everybody up and running. Next slide. Give you a little flavor of the Rare Parts collaboration scope, what we've had to, let's say, deal with over the years and what we still perform. We do benchmarking state-of-the-art that involves evaluating vendors and specific additive studies. We do standard part fabrication evaluations, and we have traditionally used a part that we created through our NASA partner, Ken Cooper at Marshall. So, and a copy of that is in the bottom corner. We've also done equipment installation and evaluations. Next slide. The rare parts collaboration scope involves also software and data capture evaluations. We look at the products, both the hardware and software sides of reverse engineering. And we have developed through the DOE facility at Kansas City, which is a NSA facility, has developed what we call AMBER, and that's our test piece for evaluating reverse engineering systems. Next slide. One of the hallmarks of our project has been technology transfer and leverage. Over 100 installed machines are available to this team within the team, members of the team. We cover almost every single type of additive application and additive process that is currently commercially available. Roughly 60-40 is the percentage of polymer to metal machines, and the metal side is growing rapidly. Our leverage investment value to date is 6.21 to 1 in terms of the return on the DoD's investment. Next slide. This is a sample copy of an ongoing database that we maintain on the case studies that the team members have run and reported to us. This is the type of information that we collect. So that when we say we have so many dollars of cost savings in a year, we've documented all that. We've documented the process that they went through to create the part. And then we've done projections out over the weapon systems that are out in the field. Next slide. The benefits of team collaboration. This slide I stole from one of the presentations that our team members did at our 213 partners meeting, and I just will go over the big highlights because it'll become evident later. But we're seen as an invaluable resource to each other for additive information and experience. We do networking among each other, with other entities, and the thing that everybody prizes most is the collaboration and the partnership and the family kind of camaraderie that this team has. Next slide. Here you can see the number of members that we have. The RARE team is composed of all of these entities, which I will not take time to read off to you. You can check them all later. There are some, I think, 22 members. Some members have 2, 3, 4 people participating on the team. So I have counted at times up to 42 people who are involved in the rare parts team. Next slide. This one is an eye chart. Sorry for that, but it's mostly made available for you when you get your printed copies. This is the typical quad chart that gives you a lot of information about cost projections, readiness savings, and what you will find there is that someone has to turn off their audio, please. We're getting feedback. Thank you. The actual realized cost savings is documented at $7.12 million per year, and that's documented with about the costing information on only 40% of the 126 case studies that we have information on. So if we were to have 100% of that number could likely double. Now the readiness improvements, we see 50 to 90% cycle time reduction, and the realized time savings for the parts that we have case studies on has totaled 1,479 weeks. And that's just for those single parts that are documented. Next slide. I want to introduce some team member examples. One of the things you're going to hear this afternoon is you're going to be hearing from all of our government partners, and they're going to go in extensively as to how they've applied these technologies. But we don't very often hear from our industry partners how they're using it. Most of the time, it's because it's on a proprietary application. They're willing to share their additive experiences, know-how, and lessons learned, but we don't know the products. But next slide. This is one that has been shared with us by Lockheed Martin. And this is a composite layup tool that is used on a missile weapon system. And by using additive as a substitute for the old methodology for creating the layup tools for this part, they saved 70% of the fabrication cost and 80% reduction in fabrication time. And that was a huge benefit to their production schedules. Next slide. This is a picture of a new model car, showroom level prototype that was produced by General Pattern. I cannot identify any further for you. Next slide. Again, they did the internal panels. Next slide. This is made available by ATI and Metalflow. This is a display and training model. It is a fully functional unit. All of the internal parts that were made with additive processes are functional and actually operate. Next slide. This is an example of a very common application throughout industry, and that's using additive to create gauges and other tooling. This gauge is for label positioning. Next slide. This is made available by Metalflow. This is also a Metalflow slide. This is a very common application that could be duplicated in almost any depot. This is using an SLA process to build a tool. And you'll see that if you examine this, this is a 3-piece tool, and it's for the molding of silicone parts.